How's it going, everyone? So we've got 3 problems in this video here that all have to do with like the circumference of a circle or maybe like a portion of the circumference, which we're going to refer to as an arc length. Okay. So in, let's see, part A, we're going to try to find the length of the arc from P to R. Now, I just mentioned that that is a portion or a fraction of the whole circumference. Okay, so for the whole circumference, let's go like from R all the way around back to R again, right? So that blue arc that I drew is just the circumference, and the pink arc is a portion of it. So let's go ahead and set up a ratio then, right? So we could write PR, right, or the measure of that arc, is a fraction of the whole circumference. Now, these arcs and circumferences are related to their central angles, right? And so for that pink arc, we have a central angle of 100. And then for the full circumference, well, how many degrees would that be if we went all the way around? Well, 360. So we have another ratio of the central angles. 100 degrees, and then 360 degrees. And these 2 ratios are equal, right? The length of the arc is proportional to its central angle. All right, so let's now calculate the circumference of the circle because we know its radius is 12. So we can write the measure of arc PR, or its length, is a portion of the circumference, which is 2 pi r. And that will be equal to the ratio of the central angles. All right, so if we substitute 12 into the radius, then we would have, I guess we'll move over here, the measure of the arc PR divided by 2 times pi times 12 is equal to 100 over 360. And then 2 and 12 gives us a product of 24. So the measure of arc PR is a fraction of the circumference, 24 pi, which is proportional to the central angles, 100 over 360. Okay. So at this point, we're ready to solve. We're going to go ahead and multiply both sides by 24 pi. Okay, anything divided by itself is 1, so we can get those to cancel. The measure of the arc PR is equal to 100 times 24 times pi, all divided by 360. So we could leave our answer like that. I'm also going to simplify it and then just convert it to a decimal. Okay. So 360 and 100 are both divisible by 10. So we get 10 and 36. And then 36 and 24 are both divisible by 12. So we would get 3 and 2. And so we get the measure of arc PR is 20 pi, that's the numerator, over 3. And the length is a distance, so its units would be linear units or inches. Okay. Right. So we'll also use 3.14 as an estimation of pi to get a decimal approximation to this length. Okay, so 20 times 3.14, all divided by 3, is going to be about 21 inches. More or less. Okay. So if I was going to like, Home Depot or Lowe's and I needed to get some material for this arc, right? I couldn't just say, oh, I need 20 pi over 3 inches of material. They wouldn't really know what to do with that kind of description. So I'd have to, convert it for them 21 inches. Okay, part B, let's find the circumference of circle P. Okay. So the circumference of circle P is going to be the whole length around, so from R to R. But as you can see, we have a partial length, right? Which is this arc length of 6.5 meters. Okay. So let's set up a ratio of the partial circumference to the whole circumference. Okay, so 6.5 meters, that's the pink arc, and divided by C. C is going to stand for the circumference, which we'll calculate in a bit. Now the ratio of the arcs is going to be proportional to the ratio of the central angles. So for the pink arc, we have a central angle of 130 degrees. And for the full circumference, well, that would be a central angle of 360. All right. This seems rather straightforward. I think we're just going to cross multiply. So that's 130C equals 360 times 6.5. Let's just divide by 130 now. And we get C. Use our calculator to estimate this. Okay, 360 times 6.5 divided by 130, 18. Okay. So we need to also include units on our answer. And so since the arc length was measured in meters, then the whole circumference, which is still a length, is going to be meters as well. All right, that brings us to part C, the final part of this question. Let's find the measure of the arc JK. So that is referring to the central angle here. So let me just call it X. Okay. So what angle there would produce an arc length of 21 meters? All right. So that arc length, again, is just a portion of the whole circumference. Right? And so we're going to create a ratio of those two values. Right? So 21 is the length of the pink arc, and then I'll just use C to represent the length of the circumference. We can calculate it because we do know the radius. All right, and that ratio is going to be equal to the ratio of the central angles. So X is the central angle associated with the arc of 21, X degrees. And then what central angle would be related to the whole circumference? Oh yeah, that's 360. All right, so let's go ahead and I guess off to the side, we'll calculate the circumference. It's 2 pi r, so that's 2 times pi times 14.32. And then if you multiply those, that's going to be 28.64 pi. All right, so we can use that in place of the circumference variable. So 21 over 28.64 pi is equal to X over 360. Okay. And then let's multiply both sides of our equation by 360 to isolate our variable X. So X is equal to 360 times 21, that's the numerator, and then 28.64 pi is the denominator. And then we'll use our calculator now to just get an estimation of that. Okay, so let's try that again. 360 times 21, that's our numerator, divided by 28.64 times pi, that's our denominator. We get about 84. Okay. Now, what units does this answer have? Okay, so X, remember, was a central angle, and angles have units of degrees. So this is going to be 84 degrees. Now, you can convince yourself that this answer makes a lot of sense, right? Because just look at that angle, right? It's almost looks like a square angle, almost looks like it's 90 degrees. It's a bit less. And so it shouldn't be that much of a surprise that our answer is just a little bit less than 90 degrees. All right, thank you so much for watching.